Hello everyone. Welcome to the webinar on Python application development for rapid prototyping under Intel Higher Education Challenge 2017 around cyber physical systems. Let us see what all we are going to discuss in this webinar. Firstly, we will have a quick recap of embedded Linux on Intel Edison, introduction to Python programming, real-time applications of Python, and Python scripting for Intel Edison. In our previous webinar, we had discussed embedded systems and embedded Linux application development and what all developer options are available for Intel Edison embedded application development. We had also talked about Linux shell scripting and Linux text editors like VI and VIM, which will be used in this webinar for Python application development. Python is a widely used high-level programming language for general-purpose programming.
Python is a design philosophy which emphasizes code readability, and its syntax allows programmers to express concepts in fewer lines of code. Python is considered as a scripting language. A script or scripting language is a computer language with a series of commands within a file that is capable of being executed without being compiled. Python is a very good example of server-side scripting language. Python is an interpreter language, which means Python directly executes instructions written in program without compiling them into machine language. Its runtime handling makes it easier to locate and fix problems in code. Python's very clean syntax and indentation-based program structure makes code much easier to read and maintain. It comes with many standard libraries useful in collecting, parsing, and storing data from the web. Its vast standard libraries allow rapid development of functionality. Python is often used as a support language for software developers to build, control and manage, test, etc.
Let's see some general applications of Python now. Python offers many choices for web and internet development frameworks, micro-frameworks, and advanced content management systems. Python is widely used in scientific and numeric computing for the collection of packages for mathematics, science, and engineering. This is also used for data analysis and modeling library. As Python is a powerful interactive shell that features easy editing and recording of a work session, it supports visualizations and parallel computing. The GUI library is included with most binary distributions of Python. In education sector, Python is an easy language for teaching programming, both at the introductory level and in more advanced courses. Now let's have a look into some real-time applications. Forecastwatch.com gives an accuracy of weather reports from AccuWeather, myforecast.com, and the Weather Channel. Over 36,000 weather forecasts are collected every day for over 800 US cities and later compared with actual climatological data. These comparisons are used by meteorologists to improve their weather forecasts and to compare their forecasts with others. They are also used by consumers to understand the probable accuracy of a forecast in a better way. Forecastwatch.com is built from 4 major architectural components: an input process for acquiring forecasts, an input process for acquiring measured climatological data, the data aggregation engine, and the web application framework. ForecastWatch.com is a 100% pure Python solution. Python is used in all its components from the back end to the front end. Frequentis is one of the world's leading providers for safety critical solutions in the field of air traffic management and public safety and transport. And it also provides innovative user-centered solutions to its customers. Frequentis has been using Python in its TAP tools, which focus on the tower and airport tools segment of air traffic control. These tools are used by air traffic controllers to track weather conditions, control runway lighting, and to monitor and control navigational aid instruments. LibMRAA is a C or C++ library with bindings to Python, JavaScript, and Java to interface with the input-output on Galileo, Edison, and other platforms with a structured and same API where port names or numbering matches the board that you're working on. It is a low-level library written in C++ that offers a translation from the general-purpose input-output interfaces to the pins available on the Intel Edison boards. Use of libmraa does not tie you to specific hardware with board detection done at runtime. You can create portable code that will work across the supported platforms. The intent is to make it easier for developers and sensor manufacturers to map their sensors and actuators on top of supported hardware and to allow control of low-level communication protocol by high-level languages and constructs. UPM is a high-level repository that provides software drivers for a wide variety of commonly used sensors and actuators. These software drivers interact with the underlying hardware platform through calls to MRAA APIs. Now we will discuss Python programming for Intel Edison. For that, the required hardware materials are Intel Edison kit with Arduino breakout board, 2 USB 2.0 A to B cable, one is connected to J16 USB port and the other should be connected to J3 USB port. For that, the required hardware materials are Intel Edison kit with Arduino breakout board, 2 USB 2.0 A to B cable, one is connected to J16 USB port and the other should be connected to J3 USB port of your Intel Edison expansion board. And then we need external power supply to power up the board with a personal computer. We also need a SSH client like Putty or Teraterm for Windows to access the Linux operating system of the Intel Edison. As we discussed in our previous webinar, we need a SSH terminal to access Linux of Intel Galileo. Here, we are using Teraterm application as SSH terminal. After downloading the Teraterm, run it as an administration. As we are using here USB serial for communication, we have to select serial. In that, we need to select that COM port which is connected to USB serial port. To set the baud rate for serial, go to Setup in menu bar and then click on Serial port. Once you click on serial port, a pop-up window will appear as shown in figure. In that, select baud rate 115200 from the drop-down list and then click OK. Once baud rate is set, hit enter, then you can able to see Edison login. Type root as login ID and if it is secured with password, enter your password. Now you will be in root of Intel Edison. Now to start with Python scripting, as already discussed in our previous webinar, we have to Once you click on serial port, a pop-up window will appear as shown in the figure. In that, select baud rate 115200 from the drop-down list and then click OK. Once baud rate is set, press enter and then you'll be able to see Edison login. Type root as login ID and if it is secured with password, enter your password. Now you will be in root of Intel Edison. Now to start with Python scripting, as already discussed in our previous webinar, we have to go for VI text editor to write the Python script. To start scripting, type VI space your program name with extension .py on the serial monitor. Press enter and you'll see a text editor which will be empty. Now press I to get into insert mode and then type your program. Once you're done with writing the program, press escape to come out of the insert mode. Next, to save and exit from the text editor, type :WQ, where W is to save and Q is to quit, and finally press enter. Now you will be in root directory of Intel Edison. To run the program, type Python space your program name with extension .py and press enter. The program will be running and at the meantime you can see the onboard LED DS2 of your Intel Edison board blinking for every second. To stop execution of the program, press Ctrl Z. Please find the links for LibMRAA APIs and UPM sensor library for different manufacturers. For further queries, please contact Foundation for Innovation and Collaborative Education at info@fies.in or mentor@fies.in. Also, you can visit our website at www.fies.in. Thank you and have a nice day.